Alright, this is 5.3 polynomial functions. Now we have done this in the past and we have talked about end behavior before, but we have never written this mathematically. Alright, now what this says is if you have a degree even function and the coefficient is positive, such as this, okay, you would have a function that looks like this, okay? Now if it's even, all this is saying is if x goes to negative infinity, which means to the left, if x goes to the left, y is going to positive infinity, which means up. So basically as you go left, you go up. Okay, and similarly on this side, that means that if x goes to positive infinity, which is to the right, y is going to go up or towards positive infinity. So if you ever see these symbols, even if they don't graph the function, you would know that that's going to be a degree even with a leading coefficient that is positive. Remember, an even function could be a quadratic, it could be a quartic, it can be an x to the 6th power, x to the 8th power. Okay, now if this is degree even, then obviously this would be backwards. If it's degree even with a negative coefficient, such as negative 2x squared, okay? So if you have something like this, this says the same thing but backwards. It says x goes towards negative infinity, which means to the left. Y is going to go towards down, negative infinity. Okay, and similarly, remember you can have other functions that are also even. Now if this is degree odd, now remember odd and positive, right? Odd and positive, such as I don't know, 2x cubed would look like this. Alright? Now, what this mathematically is saying that as you go left, right, left, y is going to go down, and as you go to the right, y is going to go up. Alright, so if you ever see this symbols right here, that's describing a degree odd with a leading coefficient that is positive. Right, also remember that you can have other ones that are odd, such as this one. That would be a degree odd and positive. Okay. Now similarly, finally, at the end, mathematical symbols. For these, they just mean the same thing but backwards. As x goes towards negative infinity, f of x is going towards positive, which means up. Right? If x goes to the right, notice that I'm saying right, y goes down. Okay. Now all this stuff is talking about stuff that we have previously discussed before, right? So I'm only going to do a couple of examples for you. So on this one right here, they're asking us to describe the end behavior. Now on this one, obviously you can see they're both going up, all right? So the end behavior, what we're going to do is we're going to look up if it's degree even and positive, right? They're both going up. The symbols are going to be exactly like this. So essentially all I'm writing is this again, but on this one. Okay, so I'm going to write as f of x goes to positive infinity as x goes to positive infinity. Notice that I'm not writing the positive. If I just write infinity, that just means positive infinity. Right, I'm going to write the other one as f of x goes to negative, to positive infinity. I'm supposed to copy that exactly as I see it. X goes to negative infinity. So for me, it's always better to read from left to right. All right, now it also wants to determine whether it represents an odd or even degree function, which again you can look at it by looking at these or just look at the graph. That should be degree even and positive, right, because they're both pointing up. And then finally they're asking for the number of real zeros. Remember, real zeros, what that means is the x-intercepts. Alright, so let's see how many times you cross the x-axis. 1, 2, 3, 4, 5, 6. Okay, so 6 real zeros. So it's going to cross that 6 times. Alright, let's do one more over here, number 3. Same thing, look at it. Alright, notice that this is a degree odd and negative. So we're actually, essentially, all we're doing is we're going to copy this 2 statements for part A. Alright, so for part A, we're going to say as f of x goes to positive infinity, as x goes to negative infinity. And f of x goes to negative infinity as x goes to positive infinity. Alright. Now look at it. You can either look at this one or you'll be able to realize this is a degree odd, right? One arm up, one arm down, and that's going to be negative. Then finally, how many real zeros do we have? 1, 2, 3. Okay? So that's all we're doing for that. Now on the back, Alright, this part is actually pretty simple. They're asking you, what is the degree of the function? We already talked about this in the past. The degree of the function is going to be the highest exponent that you see on here. It doesn't matter what order is written, right? So for example, in this one, the degree is going to be 4. And it's also asking for the leading coefficient, right? So this LC that I wrote here is the leading coefficient. The leading coefficient is whatever number is attached to the variable with the highest power. In this case, the leading coefficient is 3. All right, so this is degree 4 and positive, essentially. All right, on this one right here, notice that on this one it's out of order, but if you look at it, this has the biggest power, so therefore the degree is going to be 7, and the leading coefficient is whatever number is attached to it, like 10. Right, on this one, let's take a look at it. Again, look for the biggest power on here. Power attached to the variable, that is. So that's going to be the biggest power, so therefore the degree is going to be 8. And the leading coefficient, well, just look at this. Look at the number that's right beside the variable with the highest number. In this case, that's also going to be 8. Okay? Now in this one, if you look at it, it says that if it's not a polynomial in one variable, and explain why. Well, this one is not a polynomial in one variable because you have 2 variables, right? So I'm not even going to bother to write that one, but again, you have 2 variables, so that one I'm not going to do anything to it. Well, in this one right here, this is going to be degree 5. Again, that's the biggest power, and the leading coefficient is going to be negative 9. And maybe the hardest one on this one right here would be, let's just look for the highest power first. We have degree 6. Now this one right here, the leading coefficient, might be looking at it, you're like, well, I don't see a leading coefficient. Remember that x to the 6, or negative x to the 6 over 25 can be rewritten as negative 1 over 25 times x to the 6th. Right, so on this one, the leading coefficient is actually this number right here. Alright. Well, finally, let's go over the last 3 points that you probably have done in the past. Right, on example number 7, if you see this symbol right here, if you have a function like this and you see that symbol, all you're doing is you're plugging this in for instead of x. So I'm going to plug that in here. Right, so again, I'm going to plug in an x minus 2 for x, and I'm going to square that, and I'm going to subtract 9. Excuse me. So after that, what you have to do here is FOIL. And when you FOIL, you get x squared minus 4x plus 4 minus 9. Now the minus 9 just came from here, right? So after that, I'm going to add like terms. So we have x squared minus 4x minus 5. All right, so if you are looking at this and you go, how did it get from that to that? Remember that x minus 2 squared is the same thing as x minus 2 times x minus 2. Right, so don't forget to FOIL that. Alright, finally the next few, you can check me on this one if you like, and you probably should because I really haven't checked this at all. I'm going to plug in a 2 for every x that I see here. Minus 1. Alright. Okay, so let's see what I get here. This would be 8. This would be 4. This is going to be 4 minus 1, right? So this is going to be 32 minus 12 plus 4 minus 1. So if you add all this up, this is going to give you a positive 20. That's 24 minus 1 is going to be 23. Alright, finally here for number 9. I'm not going to do it for you, but assuming I did this right, which is questionable because I didn't really check this, I got negative 3, so see if you can do that one. Alright, this should be a pretty easy lesson for you. Well, good luck.